Hello everyone, welcome to another video. We're going to be reading a few articles from this magazine. This is New Scientist magazine. This edition is a little bit old. It's from the 4th of December 2021, and that is just because I'm a little bit behind in my subscription. So I've actually got, I've actually got about 7 weeks worth of magazines to catch up on. And I thought reading with you might be a good excuse to get a bit more reading done. So I'm going to be using a pointer. And rather than read one of the long articles that's like a double spread or triple or quadruple sometimes, these 2 pages are all sort of short stories, so I thought that might be better. Although I guess it doesn't really matter if it's sending you to sleep. It doesn't really matter anyway, does it? Hey, let's get going with some of these. So this is a small article on ancient humans. Baby Neanderthals got toothy sooner. Neanderthal infants may have got their milk teeth earlier than us. A new estimate of this comes from analysis of a milk front tooth in the upper jaw of a child who lived in what is now Krapina, Croatia, about 120,000 years ago. The tooth may have emerged sooner than we expect for our own species, from the age of 4 months rather than from about 7 months. Front teeth are generally first to erupt, enabling infants to start eating harder food. Until now, little was known about milk tooth development in Neanderthals. Alessia Nava at the University of Kent, UK, and her team used high-energy X-rays to take 3D pictures of the tooth. A tooth's crown is made of enamel. This is deposited by cells in a daily cycle, which gives it a pattern of stripes called cross striations. The distance between adjacent stripes represents the amount of tooth growth in a day. The researchers used these lines to assess how well developed the incisor was at birth and how much post-birth time was needed before it was mature enough to emerge. The group checked the estimate by analysing a jawbone from a Neanderthal that carries 3 teeth and were about to erupt at the time that the individual died. The team estimates that Neanderthals began to cut their milk teeth between around 4 months and nearly 8 months of age. Modern human milk teeth typically emerge later, between around 7 and 10 months of age. The researchers say that earlier tooth eruption may have enabled Neanderthal babies to eat harder foods at a younger age than modern human babies. This could have helped them meet the energy needs of their brains, which are thought to have been slightly larger than ours. This one is about oceans. Warmer water may have got into Arctic over a century ago. Salty Atlantic waters may have been seeping into the Arctic since the early 20th century, several decades earlier than previously believed. The Arctic is warming faster than any other part of the world, and the increasing influence of water from the Atlantic Ocean, which is on average warmer and saltier than the Arctic Ocean, is likely to be leading to further ice loss. Tessie Tommaso at the Italian National Research Council Institute of Polar Sciences says it is hard to quantify what is going on as we only have 20 years of confirmed data on the interaction of these waters. To learn more, he and his team studied the Fram Strait in the Arctic Ocean between Greenland and the Norwegian archipelago Archipelago Svalbard. No idea if that's the right pronunciation, probably not. They collected a 112 centimetre sediment core from the bottom of one of the Svalbard's inlets in order to reconstruct the history of the strait. The layers of the core correspond to sediments laid down over the past 800 years, which hold clues to the properties of the ocean at the time they were deposited. The team found that for the earliest 700 years or so, nothing changed in the composition of organic matter in the sediment. But in samples corresponding to the year 1907, they saw a sudden shift in the oxygen isotopes in the organic matter. This change suggests the waters became a lot warmer and saltier, says Tomaso. The researchers are unsure what caused this sudden shift. More data and modelling are needed to gain a clearer picture of what is behind it, they say. Health. Probiotic averts sepsis risk in mice. Consuming a bacterium found in soil helps mice avoid a blood infection that can lead to sepsis. Sepsis results from bacteria including Enterococcus faecalis. These can live in our gut without causing harm, but in people who take antibiotics for long periods or have treatments that weaken immunity, E. faecalis can get into the blood and cause sepsis. Now, for the first time, there is evidence from experiments in mice that consuming a probiotic can prevent blood infection. The probiotic was in the form of spores from another bacterium, Bacillus subtilis. These are dormant forms of the bacterium that don't reproduce and resist environmental damage well. On entering the gut, they activate and grow, influencing the growth of other bacteria in the intestine. Michael Otto at the National Institute of Allergy and Infectious Diseases in Maryland and his team gave mice immunity-weakening treatment that people with blood cancer often have, followed by a cocktail of antibiotics. The team then fed 2 doses of either B. subtilis spores or a placebo before giving a dose of E. faecalis the next day. The next day, the mice that had the placebo had E. faecalis in their blood, where it could cause sepsis, but those that were given the probiotic avoided blood infection. So these ones are really brief. Trees help cities stay much cooler. In some regions of Europe, urban trees help keep surface temperatures 12 degrees centigrade cooler in the... That's not centigrade, is it? Celsius. Let's start again. In some regions of Europe, urban trees help keep surface temperatures 12 degrees C cooler in summer, while other green spaces have a negligible effect. The conclusion comes from an analysis of data from 293 European cities. The effect is greatest in Central Europe. Okay, so I'm just going to make a comment on this one. This magazine is quite an intelligent magazine, and sometimes though I read things and I think, what? Did they actually have to study that to know that? So urban trees help to keep surface temperatures cooler in the summer. Well, of course they do. Trees provide shade, so the temperature on the surface, i.e. the ground, I suppose, is going to be cooler, isn't it? I don't understand why they needed to study that to know that. I mean, it's literally 2 sentences, I think, so perhaps there's more to it, but that's just what I'm thinking based on that. North America's unusual monsoon. A computer model suggests the monsoon that hits Mexico and the southwest US each summer is caused by the flow of air over the Sierra Madre Occidental Mountains in Mexico. This makes it unusual as monsoons are normally linked simply to the rapid warming of land in summer. Well, there you go. Loss of megafauna led to more fires. Extinctions of giant bison and other large grazing herbivores in the past 50,000 years raised wildfire risks. On continents where the losses were most severe, there has been the largest increase in grassland fires, perhaps because the animals ate more of the potential fuel. Okay, yeah, and then as soon as I read this, loss of megafauna led to more fires, I was like, well, yeah, of course. And then I read extinction of giant bison and other large grazing herbivores raised wildfire risks, and I just thought, well, yeah, of course, because they're not around to eat the grass and stuff anymore, are they? So it's going to catch fire. Again, that one just seems like a no-brainer. But even here it just says perhaps because the animals ate more of potential fuel. So obviously there is more going on here, and perhaps I'm thinking about it too simply, but yeah, sometimes I do just think, duh. And then sometimes, though, some of the articles are, oh gosh, they're really like they're really like intelligent. I can't think of the right word. they're hard to read because I just don't understand any of it. Bioengineering. Living ink can deliver drug or trap chemical. Ink made using altered bacterial cells can be 3D printed into structures that released anti-cancer drugs or capture chemicals. Ah, yeah, I've heard of this. Okay. The Microbial Link is the first printable gel to be made entirely from proteins produced by E. coli cells without the addition of other polymers. By embedding another kind of genetically modified E. coli within the gel, Avinash Manjula Basavana at the Massachusetts Institute of Technology and his team built living structures that either released the anti-cancer drug azurin or captured the chemical bisphenol A, which has sparked health concerns. The researchers made the ink from protein polymer molecules called curly nanofibers. First, they genetically engineered E. coli to create two types of cell. Both made subunits of curly nanofibers. One made fibers with positively charged units and the other negative. By growing a mix of the two types of cells, they produced curly fibers that cross-linked. The team then filtered the bacteria to concentrate the cross-linked fibers before removing the cells from the mixture. This produced a strong gel that had a suitable viscosity and elasticity for printing. Wow, how clever is that? By altering more E. coli to make azurin when exposed to a chemical called IPTG, then seeding these cells into the gel, the researchers created a living structure that releases the drug on demand. They also made another form of E. coli to produce curly subunits that bind to BPA, and again adding the cells to that gel. Wow, that is clever. So I thought, when I first read this, I thought this was going to be about a little structure that people can swallow, which can deliver drugs or pick up things as well from inside the body. That's just something I've heard about recently. And perhaps that is what this is talking about, but it's mainly talking about the printing process where it actually gets the cells and makes them into an ink. But then I think perhaps the ink gets put onto a structure, as it says here, and which then goes inside the body and does its job, which is pretty cool. Materials. New type of diamond created by crushing buckyballs in lab. Okay, I have no idea what buckyballs are, so let's have a read. A new form of diamond has been made. Its unique structure gives it properties that are similar to those of natural diamonds, but it is more stable in extreme heat, so may be good in tools used in hot conditions. There are two main types of molecular structure in diamonds and many other materials. Crystalline structures, in which all of the atoms are neatly organized in repeating arrangements, and amorphous structures, which are mostly disorganized. Howard Sheng at George Mason University in Fairfax, Virginia, and his team have made a diamond with a structure between these two forms for the first time. The new material, called paracrystalline diamond, is made up of small structures called paracrystallites that consist of just a few carbon atoms. There is no particular order to the way the paracrystallites are arranged. That's a nice word, isn't it? Paracrystallite. Paracrystallite. Yeah, I like that. He and his colleagues created the material by crushing a type of carbon molecule called Buckminster fullerene, or buckyballs, between 6 ultra-hard carbide anvils and at pressures of around 30 gigapascals and temperatures in excess of 12,000 degrees C. The buckyballs turned into paracrystalline diamond. Wow, cool. I wonder how much a paracrystalline diamond would be. Chemistry. You just can't keep a good super gel down. A soft gel made of 80% water has similar properties to shatterproof glass and can be run over by a car 16 times without lasting deformation. Is it deformate or deformation? I think that's deformation, isn't it? Deformation is something else. The material could be useful for soft robots, prosthetics, and wearable devices. Existing hydrated polymer networks, or hydrogels, are soft and stretchable with rubber-like properties, but under high compression they fail to bounce back to their original shape. Now, Oren Sherman and his colleagues at the University of Cambridge have created a soft and compression-resistant gel that can rapidly return to its original shape, even after being repeatedly run over by a 1,200 kilogram car. The gel contains a polymer of two types of guest molecule, a perfluorophenol and a phenol, that sit inside barrel-shaped host molecules called cucurbiturols. The guest molecules are cross-linked to each other inside the hosts, forming a lattice network. As the cross-links form through attraction of opposite charges, they constantly unbind and reform, which could weaken the gel. The group modified the phenol molecules to increase the time before this happens. so much for watching. I hope you